Audio Jungle. Audio Jungle.
Myself Narendra Singh Maurya. So guys, today we have a session of equation of motion of aircraft. So equation of motion. Okay. Now, if we'll talk about equation of motion, so there is the derivation basically. We have to write the force component. Okay, and that force component, and then we have to write one condition. What is the condition for what you are writing equation of motion? That condition is steady and level flight. All right, sir. Steady and level flight. What do you mean by the steady? Steady means unaccelerated. Okay, unaccelerated flight. What is the mean of unaccelerated flight? Means acceleration becomes zero. What is the mean of level flight? That meaning straight flight. What do you mean by straight flight? That flight path angle, which is nothing but theta, must be zero. Okay, that's the mean of it. So if I say flight path angle, okay, if it is zero with respect to horizontal, then it will be a straight level flight. Means suppose this is the aircraft, just for example. All right, so this is the horizontal. Okay, so from the horizontal, if this is what theta, if theta becomes zero for level flight, you understood? So now if you write equation of motion, okay, if you write equation of motion, okay, so as I okay, so this is the aircraft. What is the condition? Condition is steady, and second is level flight. Steady flight means acceleration becomes zero, and level flight means theta flight path angle becomes zero. All right, two condition you remember. For that you are going to write equation of motion. So for this, if you check, now this is the level flight or straight flight. If you talk about the forces acting on aircraft when it is flying condition, okay, because you are writing equation of motion, so obviously it will be on flying condition. So what are the forces? Thrust, okay, force, drag force, lift force, and weight. Weight of aircraft. Okay, if I say this is the weight, lift is the upthrust force which is acting in upward direction, okay, perpendicular to the free stream. If this is the free stream, free stream means that air coming towards the aircraft. This is the free stream, so perpendicular to this free stream will have a lift force. Then thrust is the propelling force. It will try to propel in forward direction, obviously. So this thrust will be in forward direction, and opposite to the motion of aircraft, which is the drag force, that is the resistance force. Thrust is what? Propelling force. That will be in forward direction. Yes or no? Forward direction. Basic only. Drag is the opposition force. Okay, which is the parallel to the free stream but in opposite direction. You got my point? That will be opposite direction. So opposite to the forward, that will be backward. See here, this is the backward force. Then lift, it is the upthrust force which is in upward direction, and weight which is acting towards the center of earth, that is the downward direction. That you know, very basic. Okay, now so if you write equation of motion for that particular case, so you are not going for the big equation, you just in short you are going to write for what you are writing steady and level flight. So if this is the aircraft, this is what weight, this is the lift, this is the drag, and this is forward thrust. So thrust is equal to drag and lift is equal to weight. This is the outcome of the whole discussion. No, I was trying to give this. Actually, it comes from a very big equation derivation, but in that derivation I told you one concept you have to use. What is the concept? You have to write equation, all the forces component in see, this is the forces will be acting here because this is the theta angle. Okay, so that is the flight path angle. So you have to write the force balancing, okay, in horizontal and vertical. Then you do one thing, next step you will take, you will apply F is equal to ma, mass into acceleration. Total force acting in any direction will be the mass into acceleration, and that acceleration will be zero. Why? Because it is the steady level flight, and because it is a level flight, so flight path angle theta will be zero. If two things you will do, then final result you may get it. So I am giving this result directly, no need to go for the that long derivation, that is not required. So now onward, for equation of motion, always remember thrust is equal to drag and lift is equal to weight. Okay, thrust is equal to drag and lift is equal to weight. That is the equation of motion for the aircraft when it is flying condition. All right, that you need to remember. Now few uh, things like basic, uh, like what is the stall speed, what is the wing loading and all, so that I will discuss. Then we'll go for the minimum drag condition or thrust, minimum thrust required. Okay, so here I will write first stall speed, it is denoted by Vs. So what is the stall speed? It's very simple. Take no. Okay. For this case, that aircraft is not moving in forward direction, which is V infinity or V. That weight will be acting downward. L. This is what drag, and this is what. All right, thrust. So you know L is equal to W, which is nothing but a steady level flight. So L, you know that lift force, lift L. What is the lift force? It is the dynamic pressure. What is the force? Force is nothing but pressure into area. So what is the area? Weighted area of the wing. Okay, because if this is what aircraft, so where lift will be generated? That lift will be generated here by the wing. Okay, so whatever the area here of the wing, okay, this is the tail is basically used to give the stability. Only lift will be generated by the wing only. Okay, because of the pressure difference. Na? Downside pressure will be more, upside pressure will be less. So whatever the lift force you will get, it is lift will be generated by the wing only. Okay, so that area of the wing is nothing but S. S is the area of wing. So what is the dynamic pressure? If this is the aircraft, here it is flying, free stream velocity is V and density is nothing but rho. So what is the dynamic pressure? Half rho V square, okay, into weighted area is nothing but S. And because it is lift force, so lift coefficient CL will come. What is the CL? It is lift coefficient. So what is the lift force? Half rho V square S into CL. CL is lift coefficient. That is the designing property. Okay, designing property means it totally depends on the type of wing or what type of airfoil you have used in a wing. Based on that, CL value you will have. So CL dependency, lift coefficient dependency is what? CL is the function of Mach number, M infinity, Reynolds number. Okay, these are the dependency, CL dependency, Mach number and Reynolds number. So Mach number, it means that again that like it will be defining like what type of wing or airfoil you are using as subsonic or supersonic. Now, so that's the reason Mach number we have here, and Reynolds number here you will have, that is the formula like rho VC. What is the Reynolds number? What is the Reynolds number? Rho VC by mu. Okay, so that is the uh, basically flow analysis or non-dimensional number which will analyze the flow. So if you check, CL dependency is what? Depends on Mach number, Reynolds number and alpha, which is nothing but angle of attack. These three parameters are basically main reason for CL. I mean, if you are changing Mach number or Reynolds number or angle of attack, then CL will be changing. Okay, so what is the M infinity? Mach number. What is RE? Reynolds number. Alpha is the angle of attack. So CL is the function of CL and CD. I mean, if you talk about drag coefficient also, so CL, CD and pitching moment coefficient, all three are the function of Mach number, Reynolds number and alpha is the angle of attack. Okay, that is the one short note for you. Now, so you got lift, which is nothing but half rho V square S into CL. So what is the V? And I told you lift is nothing but weight. Yes or no? So what is the V? V is nothing but 2W by rho V square S in root. Agree? Okay, V you are writing, so please take this as a CL, no? Because you have taken V that side. So this is what CL. Agree? So here you can write constant value 2W by rho S. This is the constant into 1 upon CL. CL is not constant as I told you. It will change. If angle of attack is changing, then CL will change. If flow properties, Mach number, if it is changing, velocity is changing, then CL will be changed. And same thing for Reynolds number also. So CL is the variable. It is not changed. It is not constant. But weight, density, and S, which is the area of the wing, that will be constant. So what is the mean of it? Mean is velocity is what inversely proportional to CL. Okay. If you are having maximum CL, okay, so I can say if this is saying proportional inversely proportional uh, constant, if you take in any inversely proportional constant, so it will be like K, okay, it is nothing but upon root of CL. So CL, if you suppose it is maximum, then this will be minimum. When CL maximum, when maximum CL lift coefficient required, or when maximum lift is required during takeoff? Yes or no? During takeoff, and lift coefficient also required maximum during landing also. So basically, if you talk about maximum CL, where when and at what condition you will achieve, so you can say at minimum velocity you have to get maximum CL, okay, which is the mean of the operation of the aircraft during the takeoff, because during the takeoff condition you will have a very limited velocity, and that time you need maximum CL. Why? Because you need maximum lift force. So for that reason you will use high lift devices during the takeoff. Why high lift devices required? Because you need maximum CL. You need maximum CL, so you will use high lift device. High lift device. What are the high lift device? It is flaps. No? Different types of the flaps you might heard. So flaps you will use like a split flap, a Kruger flap. Yes or no? Slotted flap. So many types of the flaps are nowadays available to give instant or to give high lift uh, coefficient. To provide high lift coefficient, you will use flap. So you will get lift, maximum lift, because speed is what limited. During takeoff you cannot go with very high speed. Yes or no? The speed is limited. And what is the stall speed now? So stall speed is very simple. Vs. Vs is nothing but Vmin. So what is the definition of it? It is uh, it is a minimum velocity of aircraft required to maintain flying condition. Maintain or to sustain flying condition. To maintain or to sustain the flying condition, what minimum velocity required, that will be the stall speed. So for that reason, why I have explained here, because why I have elaborated, even I can finish here also. I just wanted to tell you what is the mean of the stall speed when it is required, and to get stall speed what device you will use. So high lift device means flaps you will use to get stall speed, because stall speed means minimum velocity, okay, and minimum velocity here you have seen. If you want minimum velocity, then you should have a maximum CL. and when you will get maximum CL when you are using high lift device, and when it will happen during takeoff. So many questions uh, and answers available here if you go through these particular points. Na? Done. So anyway, so what is the stall speed? I mean, in exam they will ask to you to calculate stall speed. So what you will do? You will write 2W divided by rho s, and CL will not be normal. It will be the maximum value. Always remember. So whenever you will calculate stall speed, you have to use maximum CL. Okay, that you need to remember. I think you got it now. Okay. Now next is nothing but wing loading. So wing loading is what denoted by small w. What is the wing loading? It is nothing but weight of aircraft divided by wing area, means W by S. Yes or no? So like here, if you normal velocity, if you check what is that, 2W divided by rho S CL. Yes or no? So here you can write 2W by S rho CL, or you can write 2 small w, which is nothing but wing loading. Okay, so why I am giving this wing loading definition here and formula also? By because in numerical directly they will give you wing loading. What is the unit here? If you check the unit is nothing but weight, means Newton per meter square. So they will give to you the data, they will give like 2400 Newton per meter square. So immediately you need to understand this is the W by S. All right, there should not be any kind of confusion. There should not be any kind of confusion. Now another one more parameters that I just want to give you, drag equation, or drag polarity. So what is the drag? Total drag, I'm talking about total drag. So total drag is nothing but, first you will write zero lift drag plus lift dependent drag. So total drag D is nothing but zero lift drag, it is denoted by D naught. I must write here D naught, and lift dependent drag DI. D naught plus DI. Why DI? Because this lift dependent drag also called induced drag, and this zero lift drag also called parasite drag. Okay. So now you have D is equal to D naught plus DI. All right. You can write in terms of uh, like dynamic pressure and all. So what is the drag force? It is dynamic pressure Q infinity into area into CD. Similarly here also Q infinity S into CD naught drag coefficients, and here also Q infinity S into CDI, which is nothing but drag coefficient. This is the induced drag, induced drag. This is the parasite drag, but now I'm writing in terms of drag coefficient. So you got CD is equal to CD naught plus CDI. Okay, that also you can write CD naught plus KCL square. What is the K? So basically you can write CDI is equal to, you have written KCL square. What is the CDI? Induced drag coefficient. Yes or no? Now you can write CDI KCL square. What is the K? So you can say induced drag coefficient factor, or you can say induced drag constant. So finally you got drag polar equation, which is nothing but CD naught plus CDI. You can say this is CD naught plus KCl square. This is the drag polar equation. How data they will give to you? They will give CD is equal to 0.005 plus 0.16 L square. Like that they will give to you. So you can say here you compare it, na? Compare what you will have CD 0.05 and what is the K is nothing but 0.1. All right. So remember this K will be 0.16 here, that is okay, but this K how to define, that will be 1 upon pi EAR. You got my point? What is the pi? Obviously pi is nothing but, I will write in next quiz so better, but here you remember this is the K. Okay, so K is nothing but, I told you, constant 1 upon pi EAR. What is pi? Constant 22 by 7 E post wall efficiency. Okay, this is the designing of the wing parameter, designing parameter, or geometry parameter you can say. Means this E value, host wall efficiency, will depend what type of wing is there. It is rectangular wing, it is swept wing, it is swept forward, swept backward, or it is elliptical wing. But that value will give to you. Don't bother about, don't mug up this value, because you cannot mug up, because many different design of the wings are available. So for how many wing you will remember the constant, so don't remember, they will give. But one thing you need to remember, that is E is equal to host wall efficiency 1 for elliptical wing. This you need to remember. This is the unique elliptical wing. Okay, this you need to remember. All right, now next parameter AR, which is nothing but aspect ratio. What is the aspect ratio? It is B square by S, means span of the wing divided by area of the wing. Understood? Just say, suppose this is the rectangular wing here. So what is the span? This is the span. This is the chord of rectangular wing. So what is S? S is nothing but length into width, B into C. This is what? Rectangular wing. Okay. So for rectangular wing, aspect ratio for rectangular wing, what you can write? B square by S, means B square divided by S is nothing but BC, which is nothing but B by C. What is the C here? C is nothing but chord of wing, or you can say airfoil. So all the information here I have given, nothing is left. Okay, if you follow this, then I'm sure you will get benefit of it. All right, so this was the basic for today's session. Okay, next class onward we'll talk about the minimum drag condition or minimum thrust required condition. All right, so keep revising the topics, do hard work. Thank you all.